Welcome to part 5 of making my house unsellable. In this video, we're going to do some networking, or at least what an electrician calls networking. And first, we need to get a conduit from A to B. I lied, that's not first. First, we need to fix something from last time. I didn't show you guys because I was ashamed, but I ran out of stud anchors and I used regular raw plugs, which are disgusting and weak, so we're going to take them out and put some proper stud anchors in. That being said, the one advantage to raw plugs is you can actually get them out. So we're just going to take the screws out, drill out the raw plug, and then we can replace it with a proper anchor. The stud anchors I use, or I think they're also called wedge anchors, do not come out. They will never come out, so you better not get it in the wrong place. As you can see, I have to put the anchor in even though the strut is already installed, because I already have conduits attached to it, and there's no way in hell I'm taking those conduits off just to replace these anchors. So that's why I'm using a sacrificial bolt to hammer the anchor in from the outside of the unistrut. Every now and then, in the middle of the night when I can't sleep, I think about how much money someone is going to have to pay an electrician to undo all of this one day, and then I fall asleep peacefully, knowing that I don't care because I'll be dead. Now that I've wasted the first few minutes of this video putting anchors in that should have been installed last week, we can start thinking about what we're actually here to do, which is run Cat 6 from our PLC cabinet to our data area. I'm not calling it a data rack because the data guys will come after me, and it's not a data rack. So we're going to start obviously in the PLC cabinet, and we're going to need a knockout because we're running some conduit. Here I am installing my super advanced chip prevention device. This device does come in multiple colors and multiple sizes, but you gotta know where to get it. Now I'm measuring out a hole for the Smurf tube, and I'm basing it on the conduits on the other side, just in case I ever have conduits go all the way across, which is a possibility. I want them to line up in the end. Here's the hole saws I use for pretty much everything. A couple people were asking about what I used. It's got this nice arbor with these interchangeable carbide hole saws. It's pretty much good for everything. Honestly, the worst thing to cut through with these is plastic because it gums up. But in terms of stainless and steel and everything else, it's pretty much the best option in my opinion. If anyone's wondering why I'm running Smurf tube and not EMT like the other side, it's because I have a made-up standard in my house where all the data is in Smurf tube instead of EMT, which is mostly because I got lazy and ran out of time when I was wiring the house, but I am gonna stick with it. Now that our knockout is drilled, we can remove our chip catching device. I will leave a link for these in the description, but I will admit they are not cheap. From our connector, we're going to hop up and hit that piece of strut with a strap up to our joists and into this little box. And if you follow the red tape, this pipe does go all the way back to our data shelf thingy.
Mission. Quest. Thank you.
Looking back, I'm really not sure why I put all these boxes in for the Smurf tubes instead of just one big trough or big junction box, but at the time, I was probably very short on sleep and kind of delirious, so this is the decision I made. Once again, I'm sticking with it. Go ahead and mark our hole in the center. Always measure everything. And drill. Beautiful. Yeah, and don't hit the Cat 6 that's already running through there. Thankfully, I only have one Cat 6 in this box and in that conduit, so pulling another one should be no problem. Here I am marking to make sure our strap is centered with our connector, and then you just go ahead and slap this Smurf tube in. They're just push connectors. You can also glue Smurf tube directly into PVC hubs. I did look that up, you're allowed to do that, but I did use connectors in this scenario. For being non-metallic, flexible conduit, Smurf tube is actually surprisingly annoying to work with. It's ridiculously stiff, and if you bend it too much, it'll break, especially when it's cold. But I don't know why I'm complaining. Running EMT would have taken way longer. So there you go. There's our conduit running done for this video. I probably could have done it slightly differently, but that's what I did, so whatever. Let's run some Cat 6. If you're a professional data guy, I do recommend you cover your eyes or just skip this video because there's going to be a lot of data sins going on in this video, I'm sure. And I won't even know I'm doing it because I'm not a data guy. But anyway, let's get a fish tape through this pipe so we can pull this wire. This is a short pull in a pretty empty pipe, so I'm not going to make a proper head for the wire because I know someone's going to comment. I don't need to do that. We're just going to slap some tape on here and it'll be fine. Trust me. And here's a little baby pro tip if you didn't know. If you're in any industry that uses electrical tape, always twist it and leave a tail for the next guy who has to get it undone. I used to get yelled at for this because no one actually taught me. So, there you go. You're welcome. Another slight downside to this Smurf tube is wires really don't pull through it very easily. I mean, this was an easy pull because the pipe was so empty and it wasn't that long. But because of the way it's corrugated, it really creates a lot of friction and things don't want to pull through it. One cool thing about corrugated electrical conduit, though, is that when it's run in a certain way, in a certain size, through a certain office building, if you use a vacuum to pull a string through, it will make this very strange UFO noise that will make everyone in the building think they're being abducted by vacuum aliens. There's some pro utilization of that tail on the tape, making it nice and easy. And now we just need to get the Cat 6 from the box through our new conduit to the PLC cabinet. Now that that's pulled, gonna leave a little loop in this box just in case I need to pull it back out. It won't be a giant nightmare. Of course, I didn't do that with the other one, but it's fine. And then put our little flatheads back in. Good to go! Now we need to run that Cat 6 to something, but first, I'm going to change this outlet because it's been bothering me. Not because it's sideways, but I don't need a quad here, and for some reason that matters, so I'm going to change it out to a single. One thing I learned with these lever lock receptacles is that they're great unless you're using an RS cover. I don't know if they're not meant to be used with one, but you have to trim the top of the receptacle to get them to work with an RS cover. So if you're struggling, get out the tin snips and start hacking away. I'm sure that's what the manufacturer would recommend. Now we can move on to getting some HDMI cables run. I also have this HDMI splitter which I need to mount. And I need HDMI cables because I already have a monitor, but it's going to my camera system. So I'm going to split off, have one go to my camera system, and one go to my programming computer. I'm sure there's other ways I could do this, but my monitor only has one HDMI input, and I don't really want to run the camera system into my programming computer, because for right now, that computer is not going to be hooked to the internet unless I need to download some software. For the most part, it's going to be air-gapped. Hopefully this mount for my HDMI splitter is strong enough. I don't know if these 3/8 bolts will hold it. Well, in all honesty, I did have to change them out to quarter 20s because the 3/8 bolts were in the way. But hopefully 2 quarter 20s will hold this. I just put it in what I considered to not be a super intrusive place. But there we go, all mounted. Let's hook up our HDMIs. Orange is going to go to our monitor. I did get different color-coded cables from Amazon. Red's going to go to our camera system, and blue will go to our programming computer. Now I'm going to jump back to the PLC cabinet where my Cat 6 is waiting to be terminated, and I'm going to go ahead and do that. Once again, I am not a data guy, so you're just going to have to deal with whatever you see. Go ahead and untwist our pairs, straighten them all out. You shouldn't listen to any of this advice because this is not what I do for a living, but when I'm done, it always seems to work. So, see, I don't even know the color code. It's pathetic. If I do it for like a day or two, I'll memorize it, but it can be months between me doing this. I do use pass-through connectors because it's way easier for me, and I do use the tool that cuts it. I did get a new Milwaukee crimper, but I'm really not a big fan of it, to be honest. I like my old Ideal one better. Don't get me wrong, I love me some Milwaukee tools, but I'm not a huge fan of this crimper. It kept not cutting one of the wires, and it was annoying me. That could also be user error. I also ran a little jumper to my PLC. Custom length. I could have just bought a patch cable, but no. We did it right, I guess. Plug everything in, and that's the data for the PLC cabinet. Pretty much done. I did run it outside of the Panduit to minimize interference. I don't think it would have been an issue. And I may redo this when I get more data cables, like if I have an HMI or whatever else happens. But for now, I did keep it all separate, and that's what it is. On the other side, we have our cables waiting for our programming computer. I don't know anything about computers, just like I don't know anything about data. So here's the computer I'm using. It should be fine for running basic PLC software, HMI software, whatever. Get everything terminated. I am plugging in the World Wide Web to this computer to begin with because I do need to download my PLC software and whatever other softwares I need to communicate. So I do have a wire going up to my Ethernet switch that connects to the regular internet, and then I have my regular PLC network wire waiting. I'm sure there's a better way to do this too, and everything's a little sloppy, but I really need to have a proper data rack. I hate to admit it, but it would make things a lot neater. So we'll go ahead and turn our new computer on, see if she works. Look at that. I can hit buttons and make things light up. Look at that product placement. Oh my god, I am a computer genius. Anyway, to start out, I did download these 3 softwares. They are all free from Allen Bradley. One of them is to program the PLC, and the other 2 are essentially to communicate with the PLC. That being said, the PLC has no power. So let's start getting these fuses in, and look at that. Now we have our pretty lights. I don't know what they mean. Just kidding. I know what some of them mean. I know what power means. And we're not in run mode, obviously, because this PLC has no program. So it's not going to be in run mode. Get our Ethernet switch powered up, and we should be able to connect from our computer now. One of those fuses was for wire F4, and F4 feeds our inputs, at least the inputs on the chassis. As you can see, F4 is on a reset push button, so theoretically, our inputs should start working. Even with no program, we should see a status. So you can see as I'm pressing the button, I am getting input 1. So at least we know the inputs are working in a physical sense. Now that we have all our softwares downloaded, we can go ahead and connect our air-gapped network. So the first thing we need to do is change our IP address. We are going to go with the classic 192.168.1, and I'm going to make the computer 1. I'm not doing a gateway. We're not leaving the computer with this network. And as you can see in RS Links Classic, this is Allen Bradley's communication software. It does not see the PLC, and that's because this PLC is not set up for a static IP address. That is what this other software does. It's kind of annoying. This should all be one thing. Come on, Allen Bradley. You guys can do it. Just make it all one free software. So we're going to go ahead and assign the IP of the PLC. We're going to make it 2. That way it's on the same network, but a different device. And this will assign the IP long enough to get online with the PLC. And once we get online with the PLC, then we can change it to a static IP. So now if we go back into our comms software, you can see that it actually sees the device, which means we were successful. Now at this point, you don't want to power cycle the PLC until you change it to a static IP, or it will go back to whatever it feels like. I didn't show changing that on this video, but if you're doing it at home, make sure you do that. Here, I'm opening up CCW, or Connected Components Workbench. That's what we use to actually program the PLC. And since we're able to connect, we're going to go ahead and create a project. And generally, you would label it with the date so you know when you modified the program. I'm just going to use a number, and I'm going to increase that number every time I make a new version of the program or modify the program. So this is obviously number 1. And if I ever modify it, it'll become 2, 3, 4, whatever. At least I'll know what the latest revision is. Every company has their own standard for that, but this is my standard. I also labeled the one input that we have wired, which is the reset push button, because we are going to label everything that we do. We need full documentation in this program, or we're going to hate ourselves later. So as we go, we will label everything. Now I'm downloading to the PLC, putting it in run mode, and seeing if it actually works. So when we hit our push button, we see the appropriate digital input become true. So we know we labeled it right, and we know our PLC is actually running. So since now everything is wired and working, we can get as crazy as we want. But to begin with, we're going to start simple. I'm just going to add a power alarm in this cabinet. That's one of the good things about a PLC. You can go as simple or as complicated as you want, and this system is fully scalable, so it can get pretty complicated. So for our control power alarm, we already had these relays ready to go, and they are monitoring different parts of the control power system, including the 24-volt side. You can see the power supplies have these little auxiliary contacts on them, and that's usually what they're used for. So we can go ahead and get a plan going. In the future, I'm probably not going to include a whole lot of programming in the videos. I will tell you what I ended up doing and what the control scheme is and how it works, but I'm not going to sit here and film every single drag and drop instruction of creating the ladder logic, because that will be absolutely mind-numbing, even more than my videos already are. So I will explain what I did overall, and I might give a glimpse of the finished program, but I am definitely not going to go into depth, because in the end, I am not a programmer, so you probably shouldn't be learning it from me. I mean, you'll probably learn something from me, but it might not be the right way, so don't take what you learn here and go mess up your industrial plant. I will not be responsible for your shenanigans. Here I incorrectly drew and then redrew a diagram of two different ways that we could do this power alarm. In one way, we could take each individual device or relay and make it a separate input. There are advantages to that because then we could have a separate alarm and specify exactly what is creating the problem, but it takes up a lot of room on your I/O. So the way we're going to do it is we're going to put all these different devices in series physically so that we only have to use a single input and we'll just have a generic control power alarm because I'm really not worried about knowing exactly what breaker tripped or what fuse blew. I can figure that out pretty quick. So we're just going to put all these right in series, and that will take up a lot less real estate with our inputs. So in terms of wiring the inputs, one thing I forgot to mention is obviously you have your power leaving your power supply, in our case going through a fuse, and then into your inputs through your control devices, but you always have to remember your reference voltage. Whether it's a 120 neutral or a 24 volt DC negative, you have to have a reference for those inputs or they will not work. I've made this mistake before. I did wire this in my last video, I just never explained it. So if you ever wire up a bunch of inputs and they won't work and you have voltage, make sure you have that negative or that neutral or that reference. All right, let's stop playing with markers and do some work again.
Had these exact scented markers.
Gonna go ahead and break the wire back out, which in this case will be purple because this is a 24 volt circuit and I have that ridiculous standard. And we are going to wire to input 0, and I actually left a space for that because I had planned to do this all along. So we're going to come off of our F4, which has already jumped out on the bottom set of terminal blocks. We're going to go through all of our devices, which is PR1, PR2, PR3, and power supply 1 and power supply 2. So if any of those things fails or changes state, we will get an alarm, and then it'll go back to our input 0, which is already pre-wired on the terminal block. I didn't have to pre-wire them to terminal blocks, but I just did that as a standard. I just wired them all to terminal blocks. I obviously could have run the wire directly from these devices to the PLC, but this is what I did. So now just wire it all up, which kind of sucks because I had all this stuff closed up and neat last video, and now I'm tearing it all apart again. But that's why Panduit exists, so it's fine. So one question I get asked a lot in the comments with these videos is, why are you putting a PLC in your house? And the answer is, I'm mentally ill. But another question I get, which I can answer, is what are you going to do with this PLC? So I have a couple projects planned for this control panel. The biggest one right now is a whole home generator, which I plan to control and monitor with this PLC, even though that is not the easiest way to do it. And then in the future, I do have plans to also have an outdoor wood boiler for my heat, which I will control and monitor. I'll probably also do some smaller lighting projects that don't require dimming, and statuses of things like the sump pump or the outside stairwell, make sure they're not flooding, just little things like that. And I'm going to hardwire all of it, so all of that requires pipe and wire. And I am aware the wireless devices now are actually really good, and it makes a lot more sense to use them, but this is how I want to do it, so you're going to have to deal with it. I also mentioned in the past that I might want to integrate this with some sort of smart home system like Home Assistant or something, but I haven't really decided how I'm going to do that yet. And I want to keep this PLC as a separate system that runs on its own, independent of the internet. So that's also going to be something that I have to think about. I got a lot of good suggestions in the earlier videos about what kind of HMI software I should use other than Home Assistant, like if I want to have a separate system that's not reliant on that. And I'm currently playing around with Ignition, which I've never used. I also got suggestions for VT or Maple, but we'll see what I end up going with. Another thing I wanted to hit on with the wiring is that I'm using all the normally open contacts on my devices. That way, when they're energized, they close and the loop is complete and my input is true. And where I work, I've always been taught that that's called a supervisory circuit, and it doesn't always have to be normally open contacts. It depends on the device. But the point is, if a wire breaks or a connection comes loose, it goes into the alarm state and I will know about it. Whereas if everything was in the opposite state, you would never know if something went wrong. So that's pretty common. I'm sure someone has a much better explanation of that out there, but it's an important concept in the industrial world, so you might want to learn it. Here, I'm just labeling the rest of the tags for the I/O that I have wired up, and I gotta say, as much as I love the old Allen Bradley software like RS Logix 500, I am glad they went to a tag-based system because it really is the way to go. It just makes everything easier, especially when you're doing HMI work. When you can just import all those tags and start making graphics, I like that. I know pretty much the whole industry, including Alan Bradley, went to a tag-based system years ago, but I can still be grateful. Now I'm just throwing together a basic program with the inputs and outputs that I have, just so that my lights can actually do something. But in this case, it's not going to be much. Once I get deeper into this project, I'll add a lot more documentation, but for now, we're just going to get it running. And for anyone who wants to analyze my whole 3 rungs of logic, remember the red light is on a normally closed contact, and I'll show you why later. But now that my little program is done, we can go ahead and download. It also does like a compile automatically. You can do that separately too, but it just makes sure everything in the program is copacetic. And we'll go online so we can see everything. So now that our program is running, we'll go ahead and do some testing. You saw our green light is on, so that's good news. I'm going to flip this first circuit breaker off to simulate some kind of outage, whether the breaker trips or it just loses power. Our state has changed in the program and our light is doing what it's supposed to do. So I'll just go through the other breakers, make sure everything is acting accordingly. So the reason I put the red light on a normally closed contact instead of normally open is the exact same reason as the whole supervisory circuit thing. I'm going to turn the control breaker off for the entire 24-volt system. That buffer module did kick in and stay on for a while, so we know that's working. But that gives us a red light even if the PLC is dead, because that's its resting state. That is its normal state. So if we lose all 24-volt power, we'll still get a red light. And if we lose all power altogether, we'll have no light. So either way, we'll know something's wrong. I went ahead and got offline with the PLC, saved my project. As you can see, I did get a UPS. I actually stole the UPS from my data area, data center, whatever. And I got a bigger UPS for that because now I have more devices, so I want it to last longer. Here's a sneak peek of the little baby generator I bought. That will be its own full set of videos, but it will be tying into the PLC. That's going to be coming in the fall. I need time and money for that, so just be patient. But we're done for this video. We got everything networked, everything's online, PLC's running. Good to go for now. So yeah, bye.